Okay, here is another example of how to analyze a polynomial from a graph. Okay, in this example, it looks like we have a negative even power. So when we have a negative even power, we're going to have a different shape than what we previously had. Okay, so the shape of this guy, so we have a negative even power, negative and an even power. The general shape is a frowny face. Okay, so with this in mind, let's try to answer some of our questions before we even have to factor or go into any of that. So let's see. Well, we can answer our y-intercept, right? What happens when we plug in 0 for x? 0, 0, everything goes to 0. This has a y-intercept also at 0, 0. As x goes to positive infinity, okay, as we go to the right, what happens? Okay, well, as we go to the right, we go down. Okay, so as x gets really, 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 really large, it looks like we're going to go down to negative infinity. Okay, and this is all based on the fact that we know the shape, negative infinity. As x now goes to negative infinity, where does our graph go? In other words, as we go to the left, where is our graph going? So as we go to the left, our graph is also going down. That's it. Frowny faces is like everything's down, everything is negative, we're sad. It's always negative infinity. So f of x also is going to go to negative infinity. Okay, and then the rest of my information, I first need to figure out my factors, and then I can go from there. Okay, factors. Let me factor out. Well, they both at least contain an x squared, and it looks like they both at least contain a 2, and I'm going to pull out the negative. So negative 2x squared is going to come out of there, which is going to leave me with an x squared here, and it's going to leave me with negative divided by positive negative. 32 divided by 2 is 16. X squared out of x squared is just it. Oh, look, we can factor that further. X squared, x plus 4, x minus 4. Okay, so to find factors, we now need to set everything equal to 0 and figure out, okay, well, where would x be 0? Okay, well, negative 2x squared equals 0, x plus 4 equals 0, and x minus 4 equals 0. So here, x is going to equal 0. Here, x is going to equal negative 4. Here, x is going to equal positive 4. Something really special is going to happen with this 0 because this 0 is what we call has multiplicity 2. Because of this square. So I'm going to put a little highlight on that, okay? 0 has multiplicity 2, negative 4 multiplicity 1, because there's a 1 out here, and same thing, 1, 1. So there's actually two zeros of zeros in this case. And I'll show you what the graph looks like if we have a multiplicity at a particular point. So our factors are that guy, negative 2x squared, x plus 4, x minus 4. The order of that doesn't matter. The zeros happen at 0, negative 4, and 4, and 0 gets a special multiplicity 2. So 0, negative 4, positive 4, and 0, I'm going to put a little star by it. Star because it has multiplicity of 2. You'll see when something has a multiplicity of 2, it's actually going to be like a bounce back point on the graph, okay? You guys also have use of graphing calculators, so feel free to graph any of this while I'm talking, and you can also see the generalized shape. Okay, x-intercepts are simply the zeros as intercepts, so 0, 0. I almost always do this backwards, negative 4, comma 0, and 4, comma 0. So we just make our zeros into x-intercepts. That's the relationships between x-intercepts and zeros. Okay, y-intercept there, we figured that guy out, we figured that guy out. Let's see where we're positive and where we're negative, and for this, I'm going to draw us a picture, okay? You guys have access to the graphing calculator, so the graphing calculators would also give you this knowledge if you just graph your polynomial, but I want to do it from scratch, like suppose I don't have a graphing calculator, how do we do it? How do we figure this out? There's also an algebraic way to do this, but I really like the visual representations. So we have our graph. We know our intercepts. We know 0 is multiplicity 2. Okay, so keep this in mind, and I'm going to show you what's going to happen when we have something cool like that. An intercept at negative 4 and an intercept at positive 4. Now we know this is a negative even. Okay, So I have to come up and I have to kind of pass through here, 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 here. And usually when we see a graph pass through an intercept, it goes all the way past it. But when you have a 0 of multiplicity 2, what's actually going to do, it's not going to go through it, it's actually going to bounce at it. So this is what I mean. So there's our x-intercepts, and this is something cool now. So we know our generalized shape is frowny face. So we're going to come up here, we're going to go through that one, and we're going to go down. We're actually going to bounce here, and we're going to make like a McDonald's symbol. Okay. Every other 0, if it has a multiplicity of 1, we actually pass through it. If it has a multiplicity of 2, we bounce at it. Okay, 0 had a multiplicity of 2, so instead of going down, because if we went down through it and back up, we'd actually have something that looked like a cubic or an odd polynomial, but we don't. In order to keep this shape, we had to bounce back up at 0 and then come back down. Okay, we'll go over this a lot more in the future. But this being said, okay, so here's our picture, and let me draw a little 0 here. That's the 0 intercept. So if that's our picture, where are we positive? Well, we're positive between these two guys. So that's -4 and 0. We're positive between -4 and 0. So we're positive in this interval, and we're positive in this interval from 0 to 4. So actually, at 0, we actually hit. So we're not strictly positive there. We actually go down and hit. So actually at 0, we're no longer positive. We are equal to 0. So we start being positive again after we bounce, okay? From 0 now to 4. We're positive again. So we're positive, we hit 0. Oh, we hit 0, we're not strictly positive anymore. Then we'd be positive again, and then when we go to 4, we're going to be negative. So interval where negative is all of this guy. So we're negative from -infinity up until here. So we're from -infinity up until, what is that, -4? Union, where are we negative again? From here on. So that's from 4 now on to, from 4 on to infinity. Hopefully you can read that. All right, so we saw something cool here. We saw a bounce point. We saw a 0 that had more than a multiplicity of 1, and kind of what that looks like in a graph. So if you have a 0 that has a multiplicity of 2, think it's going to bounce here, which is what we see here. But again, as long as we know the generalized shape of our polynomial, we can fill in a lot of this information already. And then right now, all we know how to do for the time being is to just factor to get the zeros. In the future, we're going to see a more advanced technique to get the zeros because, of course, all the examples we've seen so far have nicely factored. In the future, they're not going to, and what do we do when that happens? Okay? But in general, we always care about our zeros, our intercepts, what happens in the end, where are we positive and where are we negative? Okay? As always, if you have questions, please don't hesitate to ask.